Students, welcome to class 11 physics class. Last class we discussed about the kinetic energy, its derivation, work energy theorem. Now today we discuss about the another one type of mechanical energy, that is potential energy. As we know that mechanical energy consists with or it has two forms of energy. One is the kinetic energy, another one is the potential energy. So today we discuss about the potential energy. So, in lower classes, we also studied that what do you mean by the potential energy? That kinetic energy we get due to the motion of the body, and the potential energy it is stored in the body by the virtue of its position or its configuration in a field of force or by its configuration. That means whenever the body, object or body is at rest, it possesses the energy that will call potential energy. So it is also called the mutual energy or energy of configuration, because whenever the configuration will be changed, its state of rest, the from any one state to another one standard configuration, when it will be changed, that time the amount of work done if we calculate, and that work done is stored as the potential energy. So that configuration, that whenever the body can do the passing from its present condition to the some standard condition configuration, that is called zero configuration. It is called zero configuration. So there are various types of examples, their potential energy. So here we potential energy mainly consists, or it is related to two terms. One is the position of the object, another one is the configuration. Both are the different things. Position and configuration, both are the different things. So the here I will write two examples. One is related to position, another one is related to configuration. So, due to the position, the potential energy of water stored at the great height in dams, it is used to run turbines for the generating hydroelectricity. That is due to the position, that the water position at the high. After that, the whenever the water falls from high to lower, then its position will be changed, and using that property, the turbines will also move and generating the hydroelectricity. And due to the configuration, due to potential energy of compressed spring in a loaded gun, the bullet is fired with a large velocity on the firing the gun. That is the configuration of the bullet. Okay, in the compressed spring, it will be loaded, but the whenever the bullet is fired, its velocity is large, velocity is very high during the firing time. Okay, that is due to the configuration, and the first one is due to its position. There are lots of examples also be present mm, for this potential energy. Next, types of potential energy. There are mainly three common types of potential energy are there. One is a elastic energy, elastic potential energy. Elastic means the potential energy which is associated with the state of compression or the extension of an elastic object. Elastic object means, for example, that will be spring. Okay, it is either compressed or it will be extend. Now, during that time, the potential, whatever the potential energy we get, that is called elastic potential energy. Second number, electrostatic potential energy. The potential energy due to the interaction between two electric charges is called electrostatic. Electrostatic means this is you also studied in class 12 first chapter, electrostatic in details. So static electricity means the electric charges which stay in one place. It is not moved from one place to another place. That type of charges are called static electric charges, and the whatever the electricity is produced, that is called electrostatic. Okay, so the due to that, between the interaction between the two electric charges, the whatever the potential energy will be generated, that is called electrostatic potential energy. That interaction means either due to the rubbing, the conduction method, induction method. There are three types of method for generating the electric charges in the bodies. And third number is the gravitational potential energy, and this is also included in your syllabus because another one chapter we studied after this work for energy power, that is gravitation. So gravitational potential energy, this three types we studied in that electrostatic we studied in class 12. Elastic potential energy we studied in class 11, but it is in the second volume of the second book. Okay, second part of your physics book, it will be there. And the gravitational potential energy, it is included in the gravitation chapter. The potential energy associated with the state of separation of two bodies which attract one another through the gravitational force. You know the Newton's gravitational law, F equals to gmm by r squared. You know this one. The force of interaction between these two between the two objects will be directly proportional to its product of their masses and the inversely proportional to its square of the distance between them. So, due to this separation of this body, a force will be attractive force will be apply through this gravitational force, that is called potential energy. Okay. Now gravitational details about the gravitational potential energy. So in one word we can say that energy possessed by the body by virtue of its position on the surface of the earth. Whenever the any object means, or we can also say that each and every object on the surface of the earth, they possess the energy that is called gravitational potential energy, because each and every object the earth will apply its gravitational force. We know this one. Okay, so the gravitational potential energy of a body, GPE means gravitational potential energy, is the energy possessed by the body by virtue of its position on the surface of the earth. That is depends upon the, because we see that as the heights from the center of the earth, as the height is will increases, the force which is exert on that object, or it is also become a weaker. Okay, so that's why we mention over there the position on the surface of the earth. So how we can prove this expression of gravitational potential energy, or you can say that normally the potential energy expression will be also same. In this figure you see that one object is kept on the surface of the earth. We try to lift this object from A position to B position at a height h, and this height is much smaller than the radius of the earth. So between these two positions, or in this height, the value of g, gravitational constant g, will be taken as a constant. Okay, so whenever the object will be lifted from A to B with zero acceleration, because g is constant, small g is, that is called acceleration due to gravity, g is constant. So a force is needed to lift, a force also be needed. Without any force we cannot move any body from one position to another position. F equals to m into g, that is the weight of the body. So during this change its position, the body also performs some work. So that work done on the body in raising it through the height h, that is W equals to F into S, force into displacement. Here displacement means height, F into h. So we get mgh, and we know that in the first slide we discussed the potential energy also be measured by the amount of work done which is stored inside the object. So this work done is stored inside the body, and this work done against the gravity stored as a gravitational potential energy of the body, and the gravitational potential energy is denoted by capital U. U equals to m into g into h. This is the expression for potential energy, and gravitational potential energy also be same. Now if we consider the surface, at the surface of the earth, if we calculate the potential energy at the surface of the earth, that means at the position A position, So H equals to 0. So if H equals to 0, then potential energy will be 0, because on the position A position there will be no work done, because it will not displace, no force is applied on it. Okay, that's why the potential energy also be 0 at the surface of the earth. Clear? Okay. Now this force are two types. Whatever the force is applied, in this case potential energy, so this force also be two types. One is a conservative force, another one is a non-conservative force. But there is a lots of difference between these two forces. Conservative force, this gravitational potential energy or gravitational force will be the conservative force. We also discussed and proved also that the gravitational potential energy is a conservative force. So conservative force means the force or the work done by that force is independent of the path in which path it will follow. It does not depends on that path, it just depends only its initial position and its final position. From where to where it will displace, only that position, not the path. That means, for example, we can from here to school, we can directly we can go you by the that Sodor hospital via that one. Another one, we can also move little bit distance from that Ranchi road, from different ways, and we can also reach our schools. Okay, so conservative force does not depends upon that path, which path you follow, direct path or indirect path. It just depends on the initial position from your home to the final position, that is your school. Whatever the path you follow does not matter. That type of force is called conservative force. Here we draw two diagrams. One, the object start moving from A and reaches at point B. Two paths are there, path 1 and path 2. So in first figure, the work done by that object along path 1, WAB, that is equals to same the work done along the path 2, WAB, that is equals to WAB along path 1, that is equals to WAB along path 2, because all those paths are moving from A to B. That's why WAB path 1, that is equals to WA to B path 2. But in a second figure, you see that the path 1 is from A to B, but the path 2 B to A. So path 1 will be same. Path 1 will be same as the first one. Now the path 2, because the arrow sign also be different, B to A it will move. So if we calculate the work done by that object or the body via path 2 from A to B, so we can write this second number equation, WAB along path 2, that is equals to minus of WBA along path 2. We can write this one, not the path 1. Okay, path 1 will be the same as the equation 1, but the path 2, it will move from B to A. But if we try to find out the work done from A to B, that is equals to, we can write WAB, that is equals to minus of WBA along the same path, both at the path 2. Clear? So now from 1 and 2, we get WAB along path 1, that is equals to WAB along path 2. In place of this, we put equation 2, that is minus WBA along path 2. That means WAB along path 1 plus WBA along path 2, that is equals to 0. So the work done from A to B plus work done from B to A, total work done in a closed circuit or the closed path, that will be 0. So W closed path, this is closed path. Closed path means from which point you started, after getting the after reaching the final point, you again return back to it, your initial position, then you get the closed path. So W closed path, the path, that is equals to 0. So we can write a force is conservative if the work done by the force in a moving particle around any closed path is zero. The path must be a closed path and the work done along this closed path must be zero. Then we can say that the force will be conservative force. Okay, example, gravitational force is a conservative force, electrostatic force is a conservative force, elastic force also be a conservative force. Now because gravitation chapter is there, so how we can prove the conservative nature of the gravitational force? Two figures are there, same. One is direct, that already I discussed this, that from your school, from your home to your school, direct one path, and the one via some paths. Okay. So in first figure, we directly lift the object from A to B via some heights through that height h. And second figure, first A to C, then C to D, then D to E, then E to B. Okay. So in first figure, if we calculate the work done, because it needs a force for lifting the body, F equals to m into g. So W equals to F into AB. AB means height h, mg h. In second figure, we have 1 2 3 4 work done. Work done along AC plus work done along CD plus work done along DE plus work done along EB. So AC, that is mg into AC height. In CD there will be 0, no force apply on it, that is 0. We know this one. Plus DE, again mg, and EB 0. So now from here, if we take common mg, AC plus DE, that is nothing but h, the height or the distance from A to B. So in place of AC plus DE, we can write h. So m into g into h. So from here, we can conclude that whatever the path the object or the body followed, the conservative force is independent on the path, and here the force is the gravitational force. So we can say that the gravitational force is a conservative force. It only depends on its initial and the final position of the body. So gravitational force is a conservative force. Now some properties of the conservative force. When the force only depends on its initial and final position irrespective of path taken. If any closed path, the work done by a conservative force is 0. Okay. Oh, sorry, not, it is not necessary that it will be the closed path, but if we calculate the work done in a closed path, so for conservative force it will be 0. The work done by a conservative force is reversible. It can be returned to its initial position. Okay, these are the properties of conservative forces. Next is a non-conservative force. Non-conservative force just opposite of the conservative force. That means the object or the body does not depends on the path along which body moves. Such a force is called non-conservative force. So that type of forces are called non-conservative force. If the amount of work done in moving an object against a force from one point to another depends on the path along which the body moves, then such force is called non-conservative force. Our best example is the friction. Friction is an example of non-conservative force. Now properties of non-conservative force, it is path dependent, therefore it also depends on the initial and final velocity. It is not path independent, it is path dependent. It depends on the path, which path we followed. Any closed path, the total work done by a non-conservative force is not 0, and the work done by a non-conservative force is irreversible, not the reversible, just opposite of the conservative force. Yeah. Okay, so today's class up to this. If you have any problem, please write in the comment box. Tata, bye bye, have a nice day.